Can an AI paint things? Well, let's find out. To start off, we're going to need a ragdoll that can not only walk, but control its hand well enough to paint. Luckily, I already constructed such an AI 2 years ago. This one plays table tennis, but it's actually being told where to put its hand. So if we modify this algorithm to perform paint strokes, it should just be able to do so out of the box. Oh, and to really bring this up to date, I've greatly improved the old AI code, so now I can run about 20 of these in real time, as opposed to barely running 2. So massive team sports aren't out of the question now. Alright, the next step is to actually give the ragdoll something to paint, or in other words, create an image generator. Now, while I am a fan of generative AI, there are definitely some shady practices in the industry, and whether or not you agree with training on copyrighted data being transformative, I avoided this whole dilemma with a simple solution, by creating a new text channel in my Discord called Draw Stuff Here, which clearly states what its purpose was, and what my intentions were. Yeah, so organically sourced, cruelty-free art. Even though I recommended that people draw simple doodles, some people actually put a lot of effort into their art, which resulted in some pretty gorgeous and occasionally horrifying images. Like, look at this one. Like, how does this even work as a character? What's the diagnosis, doctor? I gotta go fast. Where's the Vicodin? So after a little while, I gathered all the images, scaled them to the same resolution, and used them as training data for an AI. Now we get into the nitty-gritty. How do you train an AI to generate images? The state of the art for this problem is stable diffusion, which involves training a U-net to iteratively remove noise from images, and this was going to be the original topic of the video until I discovered that you can't train a stable diffusion model on a 2014 Alienware laptop. So instead, we're going to use something called a beta variational autoencoder. This will actually be 2 AI. The first one, the encoder, will take any image and process that huge amount of information down into a tiny package called the latent space. The second one, the decoder, will take this latent space and turn it back into an image. Now the goal here is to make the 2 AI mirror each other. The encoder will compress the image like a hydraulic piston, and the decoder will try and recreate the original image from that. The reason this works is that the latent space doesn't even come close to representing the original image anymore. So the decoder is forced to hallucinate most of the image itself. So by feeding it artwork as training data, the decoder is forced to figure out how art works. Once the encoder and decoder are trained, we can simply sample random latent spaces and give that to the decoder. The decoder will then create an image out of it, which will still have the qualities of its original training data, but it will be distinctive. Now, the beta VAE will also have a secondary goal, which is to appear random. So instead of generating latent space directly from the encoder, we will instead output means and standard deviations, which are then sampled from randomly. This essentially forces the decoder to learn that things that are close in the latent space should look similar to each other. So instead of learning things like this, it looks more like this. It took me several attempts to find that Goldilocks zone for training an AI like this, but eventually I wound up with a model that could generate decent images, some of which were really cool, and some of which were downright terrifying. Oh good god, that's fucking creepy. As interesting as this is, we haven't actually painted anything, so let's address that now. For each image, we are going to generate a set of brushstrokes that indicate its colour, a direction, and the pressure of the stroke, which hopefully once they're all applied to a canvas, resembles the original. As weird as this sounds, this problem, stroke-based rendering, is well known, and Aaron Hertzman even has a PhD on it. A PhD in art, generated by a computer. A statement more ironic than a fire station burning down. For this, we will follow a generic algorithm outlined in his thesis. Before we begin, we will need a colour palette. For this, I used k-means clustering, which is a method of iteratively identifying groups in large sets of data. I then treated each pixel as its own colour vector and ran the algorithm on that. The cool part about k-means is that you actually get to choose how many groups you want, so I had full control over how detailed I wanted the shading to be. Once we have a palette, the painting process begins. First, we will blur the image and measure how bright each pixel is. Then, we will apply something called a horizontal and vertical Zobel filter, which essentially measures where the horizontal and vertical edges of the colours are. We then combine the horizontal and vertical edge fields together, which gives us a new field that shows how each edge in the image is oriented. We then use this field to guide paint strokes, treating each stroke like a particle that is flowing through it. Starting with a white canvas, we will pick a random pixel and check its difference in colour with the original. If it's over a threshold, we will initiate a paint stroke there using that colour, which will be guided by the field until it either becomes too long, hits the border, or the colour at the current position differs too much from its source. Typically, hundreds of paint strokes are done in order to fill the canvas. We then repeat this whole process with different brush sizes, typically going smaller and smaller. This allows us to quickly fill in the canvas with a big brush at the start and then work on the details later. For my paintings, I found that having 4 brush sizes with 400 strokes each gave really good results. Let's summarize what happened here. We've taken art, trained an image generator with it, modified a ragdoll to paint, and created an algorithm to turn images into paint strokes. And the result of all this hard work is this, and these. And honestly, knowing that a humanoid AI imagined and painted all this makes me appreciate them a bit more. Now, what are we going to watch it paint first? Ah yes, Brilliant. If you want to create something similar to what I've shown in this video, Brilliant pretty much covers every topic you'll need to do it. Whether it be the k-means clustering, the probabilities, and the maths involved in reinforcement learning, or simply how to recreate algorithms from a thesis, you will learn it step by actually doing it in interactive lessons. Pretty much anyone aged 10 plus can use this, and the courses are crafted from world-class teachers from MIT, Harvard, and Stanford. You're so right, French Binkus. The How AI Works course specifically covers image generators and how to train pretty much any AI yourself, while the Clustering and Classification course will cover k-means clustering, and the Probability and Chance, Coordinate Geometry, and Coordinate Plane courses will give you the background you need to extend your AI knowledge to reinforcement learning in 3D. So what are you waiting for? Get Brilliant free for 30 days with the link brilliant.org/B2studios or scan the QR code. This also gives you 20% off a premium subscription, so join now. Now, if you'd like to watch more of this AI painting thing, let me know in the comments because I'm planning on making a multi-hour version of this. But other than that, enjoy the time lapse.